In this video, we're going to discuss trigonometric functions. Before we discuss trigonometric function, let's talk about what is a function first. So what is a function? A function in general consists of three parts. First part is a set of input quantities, and is also known as domain of a function. Second is a set of output quantity, which is known as range of a function. So we have an input quantities of a function, and output quantities of a function. And third, we have a rule that assigns each input quantity to exactly one output quantity. So these three things are all important for a function. So essentially, a function is a relationship or rule that assigns an input quantity to exactly one output quantity. So this is very important. Essentially, this one line sums up what a function is. We have an input quantity, and input quantity is assigned to exactly one output quantity. So there are many ways to describe this relationship in words, graphs, lists of ordered pairs, tables, and expression. And because we're in math class, we often use graphs and equations. So equation is just one way to express a function. So let's talk about trig function notation. Well, actually, sorry, function notation in general. Okay, so then we'll look at specifically trig functions. So function notation, we use y equals f of x, defines function named f. This reads y is a function of x. So this is general in any math class. We use f of x or y equals f of x. The letter x represents the input quantity or independent variable, or the letter y represents the output quantity. So here's a good picture to demonstrate what function notation is right here. Right here. So this notation inside right, this refers to input quantity. And this f is just a letter for the function name. So it can be f, t, g, a, anything that represents function name. So we have f of x, and this entire thing, f of x, represents the output. Symbolically, it represents output. But how do we actually evaluate that output? We use this rule or map. In this case, the equation x to the third minus 2. So if I plug x equals 1, I plug 1 to the third minus 2, gives me negative 1. Negative 1 is the output value for input value x equals 1. And this entire thing we refers as function definition, a specific function definition. So how does this relate to a trig function? Well, in trig function, we have an input, and that input is angle. Can be angle in radian, angle in degrees, but in general, it is angle in radian. Okay, we can apply it to degree also, but in terms of when we're defining specific trig function, we examine with angle in radian. So input is radian, and output, what is output? Well, that depends on which trig function we're talking about. Okay. So just know that for now, trigonometric function takes input as an angle. Angle is the input. So let's look at the first trig function called sine function. Okay. So sine, y equals sine theta. And like I said, this theta, even if it's not written theta, even if it's written in t or x, it's always implied that sine of something, this something is an angle quantity. Angle measurement. So the sine function relates the angle measure to the vertical height of the point above the horizontal diameter. So here, only thing we really need to have a sine function first is angle. And what is the rule? The rule is that we input an angle, and output is essentially this distance right here. This distance is the output. So let me write that first, and I'll explain furthermore. So input for any trig function, input is angle. So we insert angle. So let me write here. This is something I'm repeating a lot. And that's how important this is. Input is an angle. And output, I know it's kind of wordy right here. Output is vertical height of the point above the horizontal diameter. This is the output. So here I insert this as an angle. So here's the initial ray and terminal ray, right? Well, what is the vertical distance from the horizontal diameter of the terminal ray's position? Well, this is the sine of that angle. Okay. So this is kind of overview. Let's look at a specific definition what sine function is. Okay. So sine, again, input of angle in radian, and then sine of that angle represents the vertical distance measured in radius length, or radius length, of the point on the circle above the horizontal diameter. So measured in radius length is just like the radian. Radian is measured in radius length. Okay. So in order to measure this distance, the units of radius length, we need to find the ratio of the vertical distance to the radius as measured in their given units. Or in this diagram, b over r. Therefore, we can write sine theta equals b over r. So let's really examine what sine is. So let's define this arc length. Let's say this is just letter S. And this represents arc length. So we have angle arc length over radius length. So this is radius right here. Or this is also same radius, right? R. So this is angle in radian, right? This is in radian. So sine takes the angle in radian, and output is, let me do this. Here's a terminal ray of the angle, right? So angle initial ray, terminal ray. So here's the angle, right? This is the angle. Well, this is the input angle, arc length divided by radius length. The output is this vertical distance from the horizontal diameter. This vertical distance measured in radius length. So we divide by radius, or we can think it's divided by this radius. Okay, so that's what sine function is. Sine, let me write it here again. Maybe let's put it this way. Sine takes arc length divided by radius length, which is essentially a radian, right? So this is, let me write here, angle in radian. And the output is this vertical distance, b, measured in radius length over r. So how many times radius length can go into this vertical length? So that's what sine function is. And this is one of the reasons why the angle in radian is so important, because it relates. You see how arc length over r, the b over r. So sine length essentially relates the angle in radian with the vertical distance measured in radius length of the terminal ray. So let's get cosine function. Cosine function also, I'm going to keep writing this because it's important. We have to always remember the angle is the input of the function for any trig functions. So this is input. Okay, so input again is an angle, just like sine. So for cosine function, it relates the angle measure to the horizontal distance. So not vertical distance now, it's a horizontal distance of the point above the vertical diameter. So in this picture, we have this angle right here. Well, what is this distance measured in radius length? That essentially is the cosine value. So let me write that. Output is essentially the horizontal distance above the, or we can say from the vertical diameter, measured in radius length. So let's look at the formal definition of cosine function. For cosine function, again, the input of angle in radian. Cosine function represents the horizontal distance of the point circle right of the vertical diameter. To determine distance in radius, we must divide actual distance by length of the radius length. Therefore, cosine theta equals a over r. So let's look at this again. Let's say we have arc length. Let's label the arc length as s. So then we have angle in radian, arc length divided by radius length, whatever radius length is of the angle or the circle. And a is just this length right here. A is this length. This is a. Let me just box it. So here I have this angle. Okay. So for this angle, the terminal ray goes this way and ends right here. This is a terminal ray. So in this terminal ray, what is this distance? Terminal ray ended here, right? So we can think two ways. Here's the vertical diameter. What is this distance? Well, it's a, but we need to measure that in radius length. That's what we divide by arc length. So we have, again, cosine of arc length divided by radius length equals a, the horizontal distance from the vertical. So this is the horizontal distance, right? This length and the same horizontal distance from the vertical radius for that terminal ray of the corresponding angle we're dealing with. Again, this is angle in radian. Angle in radian. So this is what cosine function is. For cosine function and also for sine function, we have an angle. So trig functions is dealing with the angle and certain distance, right, as an output. So let's get another trig function. It's called tangent function. Tangent function also relates an input as an angle to the slope of the terminal ray. So for tangent function, we get an angle. Hey, what is the slope of this angle? Specifically, what is the slope of the terminal ray? And we compute that by changing output over changing input. You also maybe heard of this rise over run when you're computing slope. That's what we're doing, rise over run. So what is this value over this value? Then it will give us a slope. So for example, let's say I have angle that looks like this. This angle. Well, tangent theta of this angle, will give me this slope. What is slope of this line? Slope. So this is how tangent function is defined, which just gives a slope of the angle. Okay. And because we're dealing with change in output or change in input or vertical distance over horizontal distance, it can be also expressed as a sine over cosine. Because sine of this angle, let me just write it, sine of this angle can be, if this is radius r, although radius itself is not using tangent, it will cancel out. I'll show you in a second. So tangent of this angle right here is vertical distance over radius length. So b over r. Cosine of theta will be a horizontal distance by radius length, a over r. So if we do sine theta over cosine theta right here, we get b over r divided by a over r, which r's cancel out, so we just have b over a. So sine over cosine can be used to compute tangent values. But it's not so precise to say that tangent function is defined by sine over cosine. Tangent itself is its own function. It's just that oftentimes we use sine over cosine to compute tangent. But the meaning of tangent is that it's just slope of the terminal ray of the angle we're dealing with as input. Okay, so the one important thing I want to talk about before looking at an example is that we really need to think an angle as a varying quantity. So if I have an angle, if I'm given any angle, let's have this angle, I can find sine over cosine. I can find sine, cosine, tangent values. But think as angles changing. Well, we're not always going to have a fixed angle values, right? Maybe I have this angle next. Just like a spinning, right? This isn't the best way of spinning, but just like something things are rotating, angle is a varying quantity oftentimes. Okay. For example, if I'm looking at a let's say hot air balloon going up, as it goes up, this angle changes, right? From my ground, the angle to the ground changes. As it changes, the cosine, sine, tangent value also changes. So always think angle as an input value that is varying. It changes. Yeah, we put one angle at a time to evaluate sine, cosine, tangent, but in general, it's a varying quantity. Okay? It has multiple values. It's not a fixed quantity. Okay, so let's look at this example. So in this example, we have this angle. Okay? And radius is 5. And we have this arc length is not known, but that's okay. It won't affect us in terms of finding the sine, cosine, tangent values. But for angle in radian, we know that it's arc length divided by radius length 5. So that's the angle in radian. So let's find sine theta first. Well, sine theta, you can try to understand the meaning of it. Don't just try to memorize it. Try to understand the meaning of sine theta. Well, here's the angle. So here's the terminal ray of the angle, right? Terminal ray ended here. Well, what is this vertical distance measured in radius length? The height of this angle from the horizontal diameter is right here. 4 divided by radius length, 5. Again, you can also think as 4 divided by 5 right here, since this is also radius length. So we have 4 divided by 5. Let's look at cosine. Cosine of theta. Cosine now is relating, again, this terminal ray of this angle. Here is this length, terminal ray, this length right here, which is same as this length. So let me write the vertical diameter. Here is the distance. Here's a terminal ray. What is this horizontal distance from the vertical diameter? Well, this is the same as here, so it's 3, but measured in radius length. So we have to divide by the radius length. What is tangent value? Tangent value is this slope. Well, slope is rise over 1, so we just 4 over 3. Okay, but here's the tricky part with the pen tension. Okay, so actually, maybe I should point it out one of the cosine. This should be negative 3, because if we're following x and y coordinate oftentimes in trig function class, so let me fix that. This should be negative 3. Therefore, slope will be 4 over negative 3, which we can just write negative 4 over 3. So for cosine, we look at this vertical line, and if you look at here, this distance is negative 3 on xy coordinate, right? Because y-axis give us 0, 0 for x and y value. Then we have to go negative direction to get negative 3. That's why its cosine is negative in this second quadrant. And of course, sine can be also negative. Sine will be negative right here in below x-axis. Sine is negative here. Cosine is negative here in terms of angle. Okay. Tangent here, slope positive here, slope positive here, slope negative here, slope negative here. So depending on the angle, sine, cosine, tangent can be either negative or positive value, or 0. So let's talk about sine and cosine on a unit circle. So unit circle is a special circle that radius is just 1. That's all that is. Radius is 1, and also the origin is at 0, 0. So why is that significant? Because the angle theta is the arc length divided by radius 1. So angle is just treated as arc length in unit circle. So that makes little simpler to evaluate sine and cosine value. So look at right here. Let's look at sine value first. Sine theta is this angle input, and output is this value, this height divided by radius length. Okay? So it will be vertical length. So let's call this length y. Y divided by 1, which is just y. That's why the y value right here is just the sine value, just for the unit circle, because radius here is 1. Radius here is 1. That's why. Which is just straight vertical length. Technically, it is still measured in radius length, but radius length is 1. So we divide by 1, which you get number itself. Similarly, cosine theta, we'll get x over 1, which is just x, which is a horizontal length. Again, technically still measured in radius length, but since radius is 1, we write just x. X over 1 is x. So let's just look at the first quadrant of a unit circle. That's how it looks. And we're looking at x and y coordinate. And just like we talked about in the previous bit of angle, we look at x and y coordinate as a standard position. So in this video, we have, this picture, we have sine of t and cosine of t. So sine of t, again, input is this angle. When I input this angle to sine, I got this distance because the angle has this initial ray and this is a terminal ray for in this case, right? Here's the terminal ray. Well, what is this height? Well, that height is the sine of that angle. Okay. Measuring radius length divided by 1, which is just sine t. That's why we have sine t here. Y, the length y coordinate is just sine t. Similarly, the cosine is, here's the terminal ray of the angle. What is this distance? Okay, from the vertical radius, which is same as this distance, which is just x value, which is cosine. So in unit circle, measuring radius length is dividing by 1, so numbers a little nicer in terms of we don't have to write it as many numbers. Okay. So let's look at some special angles. In radian, we have these pi over 4 and 9° and pi over 4. So here now we're relating to a triangle. This is also known as 30, 45, 60 triangle, or 60, 30, 60, 90 triangle for the left one right here, and 45, 45 isosceles triangle for this one right here. Okay. So the reason why this is significant is that we can use the ratio. So from geometry, we know that once we have a triangle, there's special ratio. If this length is s, this is 2s, this is square root of 3 of s. And that's just for angle pi over 3 right here. Because if you have a pi over 3 here, automatically this becomes pi over 6 if this is 90. Same here, I have a pi over 4. We know the ratio is square root of s. If this is s, this is s. Okay. So knowing this can help us evaluate some of the sine, cosine, and also tangent value. So let me go to the next page. So there's a special angle. Okay. So remember, we're on unit circle, means radius is 1. This is why we have just x value as cosine, y value as sine. That's not always the case. X is cosine, y is sine, only when on a unit circle. Okay. So if you look at this angle right here, this is pi over 6. Again, pi over 6 means 1/6 of pi. Remember, in angle, this is pi. This angle is pi, right? So pi over 6 means we divide into 6 equal pieces. We have pi over 6. Okay. So then we have 6 pieces like this. So that's what the angle pi over 6 means here. And it turns out the ratio of this length, this height, is half, and this horizontal distance is square 3 over 2. And that's following the special triangle. So why does that relate to us in terms of trig function? Well, this helps us evaluate some of the sine cosine value very conveniently. So reading from here, we know that sine of this pi over 6 angle, or excuse me, that's cosine value. Cosine, because cosine is the x value, cosine of this pi over 6, this angle, is this distance. Let me do it this distance. So cosine of pi over 6 is this distance, which is square 3 over 2. Square root of 3 over 2. So then we can also find sine of pi over 6, which is, for this angle, sine, the terminal rate is here, so sine is this distance divided by 1, which is just half. So that's how we find sine and cosine of pi over 6. And we can also find sine, cosine of 45 degree over pi over 6. Cosine of pi over 4 is this value. For this angle, what is cosine? What is this distance? Well, square 2 over 2. And sine pi over 4 is also square 2 over 2. And here, this tells us that cosine of, now what is this angle? Pi over 3. That means it's 1/3 of pi. Pi over 3 is half. Sine of pi over 3 is square 3 over 2. And for tangent, we can just do sine over cosine to find for tangent of each of these values. Okay. So then let's look at this right here. This angle is pi over 2. Well, for pi over 2, here we do not have any horizontal distance, right? So that's why cosine of pi over 2 is 0. From initial ray to terminal ray, here's a terminal ray. Terminal ray. But this terminal ray lie on exactly the vertical diameter. That's why the cosine value is 0. There's no horizontal distance. Whereas sine pi over 2 is 1. This vertical distance right here, this vertical distance is 1. So this is 1. And conversely, if you look at 0 or 0 radian or 0 degree, cosine of 0 degree is 1, because this vertical distance now, think as here's the initial ray and terminal ray. So angle ends, start here, end here. What is this distance, horizontal distance? 1. That's why cosine of 0 is 1. Oops, sorry. And sine of 0 is 0, because there's no vertical distance for this angle. So for this special angle, this is just fourth quadrant, and you need to be able to construct first, second, and fourth quadrant. So here's the next picture. Next page is a picture of the entire inner circle. So you definitely need to know how to do this. When I say how to do this, it means you need to be able to construct this on your own. Because very common questions like things like this. You see in the homework is, okay, what evaluate sine pi over 6? What is that? So you draw a unit circle on your own first, and then find it. Okay, well, sine pi over 6, here's angle pi over 6. What is pi over 6? Sine is half. Okay. Another question could be, what is sine of 5 pi over 4? And we're just doing a practice problem. Angle 5 pi over 4 is here. Well, where is that? Why is the sine value? Negative square root over 2. Negative square root over 2. Again, don't just memorize, try to have a meaning. What does this mean? What does this number mean? It means that this vertical distance right here. Okay. Well, angle will start from here. Let me just draw and I'll erase it, not just be messy. So here's this angle. Okay, this angle is 5 pi over 4. For sine of pi over 4, 5 pi over 4 is asking, hey, what is this distance measured in radius length? Well, radius is 1. So what is this distance? This distance is negative square root over 2. That's what sine is finding. Okay. Let's do one example of cosine. What is cosine of 7 pi over 4? Well, 7 pi over 4 is here. So here's this angle, 7 pi over 4. There's a terminal ray. Ends here. Well, cosine is asking horizontal distance from the vertical radius. So what is this distance? Which is the same as this distance. So essentially this distance, right? So that distance right here, looking at the x and y coordinate, x coordinate, square root 2 over 2. Okay, so that is square root of 2 over 2. Okay, so let's look at one more example, then I'll kind of walk you through how you would go about constructing your own unit circle. So let's look at how would you find tangent. Tangent of, let's say, pi over 3. Well, pi over 3 is here. Tangent is the slope. What is this slope? We're going to find rise over run, which is the y value divided by x value. Square 3 over 2 divided by half. Dividing a fraction is multiplying reciprocal. So flip this one, 2 over 1, square root of 3. That means this slope right here is positive square root of 3. That's the slope. Okay, let me write that again. Square root of 3. Okay, now I'm going to walk you through, talk about how you construct this on your own. So just follow along. First, when you construct this on your own, first, draw the angles first. Angles first in radian. Okay? And then you fill in the sine and cosine value. And then sine, cosine values in coordinate like x, comma, y. So how do we go about an angle? Well, we know that this right here, half circle, half rotation divides into pi. That's why this angle is pi. So from here to here, angle is pi. Right? So this is pi, right? Pi. And we divide pi by 2. What we then with pi over 2? We have the pi, we get pi over 2. Similarly, we have pi and we go over another pi over 2, gives us 3 pi over 2. Okay, so I have pi plus pi over 2. So this amount is pi over 2. We get 3 pi over 2. And from 3 pi over 2, I add another pi, then it gives me 2 pi. Full rotation. So that, by doing that, we can construct this x and y coordinate angles. 0, pi over 2, pi, 3 pi over 2. Okay. So that's how we begin. So let me just draw maybe with the red. You draw these red x and y coordinate. 0, pi over 2. I don't want to erase the angle. First, you draw 0, pi over 2, pi, and 3 pi over 2. And then what you do is, again, it's easy to think if you think as a pi. This is pi, right? I'm going to divide it into equal four slices. So that's why I do pi over 4, pi over 4, pi over 4, pi over 4. So pay attention to this. Here, here, here. So these are 4 equal slices. Because I divide pi into 4, that's how I get pi over 4. Okay? So I got pi over 4, and I add another pi over 4. This is pi over 4 I add, and then I get 2 pi over 4, which is equal to pi over 4. Excuse me, pi over 2. 2 pi over 4 simplifies to 2 pi over 4, pi over 2. 2 pi over 4 simplifies to pi over 2. And from here, I add another pi over 4 to here, then I get 3 pi over 4. I add another pi over 4, I get pi 4 pi over 4 is pi. I add another 4 pi, pi over 4, I get 5 pi over 4. Another, I get 6 pi over 4, which is simplifies to this. I add another pi over 4, I get 7 pi over 4. Then I get 8 pi over 4, which is 2 pi. So that's how I get these numbers, these blue circle numbers right now, by adding pi over 4 at a time. Similarly, let me do it right now. Now I divide half into 1/6. So here, now, sorry, 1, 2, 3, 4, 5, 6. So there's 6 equal pieces in pi. That's how we get pi over 6. That's what pi over 6 means, right? Pi divided by 6. So here's pi over 6. Start from here. Add pi over 6. I get 2 pi over 6. 2 pi over 6. 2 pi over 6 simplifies to pi over 3. Add pi over 6. I get pi over 2 because I get 3 pi over 6. This is 3 pi over 6. 3 pi over 6. And I add another pi over 6. Then I get 4 pi over 6, which simplifies to 2 pi over 3. So this is 4 pi over 6. From here, I add another pi over 6. I get 5 pi over 6. Add another pi. I get 6 pi over 6, which is just pi. And another pi over 6. I get 7 pi over 6. Add another pi over 6. Just keep adding pi over 6, right? Then I get 8 pi over 6, which divides into 4 pi over 3. Another pi over 6. I get 9 pi over 6, which is 3 pi over 2. Add another pi over 6. I get 10 pi over 6, which is simplifies to 5 pi over 3. So 10 pi over 3, excuse me, 10 pi over 6. Add another pi over 6, I get 11 pi over 6. Then add another pi over 6, I get 12 pi over 6. So essentially, we'll keep adding by either pi over 2 for the first four quadrant, first four dividing, and then I add in increment of pi over 3 and pi over 6. That's how we achieve, oh sorry, this is pi over 4. That's how we achieve these angles. Okay, so try to really practice this on paper because you need to be able to construct this on your own. The exam, quizzes, and of course homework. Okay. So once you got the angles done, and then what you do is you find these sine cosine values. Well, let me highlight it with red. So these values, right? If you know these first quadrant values, all other kind of follow pattern. Well, if you look at here, this value and this value, these coordinates, so it's easy if you think of a coordinate. This point and this point, xy coordinate, they have the same vertical distance, but just opposite x length because one's positive, one's negative. That's why it's half, but it's negative half. So it follows this pattern. Look at this value. This point right here, this red point and this red point, they have the same vertical distance, but different x values. That's why one's negative square 32, one is positive square 32. Similarly, if you look at, I'm going to erase some of this part just to not be too messy right now. Look at this blue point and this. They have the same horizontal distance. That's why both of them are positive square 3 over 2, positive square 3 over 2. But the y value is different. One's positive half, one's negative half. So you follow this pattern to fill in all the values. Of course, in third quadrant, if you look at this angle and just follow this angle, they have opposite x and y value. Right? Here I have positive x, positive negative, negative y, negative x. So they're just negative. Okay. So you can follow this pattern to fill in all the sine, theta, and cosine theta value on unit circle. And unit circle is very important in this section. You need to be able to find these values from the unit circle. So let's look at right triangle trigonometry. So this is an alternative way of thinking about trigonometry function. Think of trig function as a, again, still takes angle measure input, quantity, and produce certain quantity from a right triangle as an output quantity. So maybe some of you have heard this term SOHCAHTOA because it's sine, OH, cosine, AH, SOHCA, TOA, TOA, because we're relating to the triangle, hypotenuse, opposite, and adjacent. So if you think that way, we pick this angle, and sine will be opposite over hypotenuse, which in definition we looked at, if there's an angle, we're thinking hypotenuse is radius, opposite is the vertical distance. And cosine will be horizontal distance adjacent divided by hypotenuse, which is essentially again radius, equivalent in terms of um, x and y coordinate sine cosine definition. And we have tangent opposite over adjacent, which is the slope. Okay. So some of you may be wondering, and maybe not, especially if you've seen this before, and we assume that you've never seen any of these. Okay. The reason why we don't always use right triangle trigonometry, even if you're used to this first, is because this kind of gives us the impression that angle is fixed. If we deal always with a triangle, sometimes we need to. Okay, this is definitely a skill you need to be able to do, but it's not always the case that we have a fixed angle. When we think of a triangle, it's already given. We don't often think as triangle as a varying quantity or changing thing, right? It is easier to think about angle as a quantity that either rotates this way or this way, positive direction or negative direction, right? So right triangle often gives us this feeling of, okay, we're dealing with fixed quantity, but how do you have a function here? Because function deals with a lot of input variables in relation to just a lot of output variable. For trig function, there's infinite number of input quantities and infinite number of output quantities. So how does that relate to right triangle if you only think about right triangle? So that's just something to keep in mind. Right triangle, again, like here, that's why I said alternative way of thinking about it. Given a right triangle, we can use this. But in the definition of sine and cosine we looked at, like right here, it's more productive to think as, you know what? We have an angle and it does form a right triangle. It's not that we are given a right triangle. Having an angle forms a right triangle. Okay. But the basis is that we have just an angle as an input. Here's some other trig functions. So it's called cosecant, secant, and cotangent. So let me write it bigger. Secant of an angle is just 1 over sine of that angle. That's how we find it. Secant, it's a cosecant, I'm sorry, cosecant. Secant of that angle is 1 over cosine of that angle. And again, it has to be same angle right here. And cotangent of that angle is 1 over tangent of that value. And we have to be careful here. The way we use these values, the way we describe this is just these names, secant, cosecant, secant, cotangent. We do not say they're inverse to each other. We do not say they're opposite. We do not use those words for describe these functions. Okay, because there's different meaning for inverse later on. So for example, we know that from unit circle, sine pi over 4 is square root of 2 over 2. Then we can find cosecant of pi over 4 as well, which is square 2 over, 1 over cosine of pi, sine of pi over 4. Well, we know that this value, which is square 2 over 2. So we have 1 over square root of 2 over 2, which is 1 times 2 over square root of 2, multiply reciprocal. I get 2 over square root of 2. We need to rationalize, multiply square root over 2 square root of 2. These, I get 2 square root of 2 over square root of 2 times square root of 2 gives me 2. Cancels out, just gives me just square root of 2. So cosecant of pi over 4 is square root of 2. So we're going to do that here. So that's how you can use these values to find other trig functions values. Okay, just know that for these you just need to remember these rules and try to avoid or don't use word like inverse or opposite. Just say 1 over sine. Similarly, cosecant can be written as 1 over sine, secant as 1 over cosine, cotangent as 1 over tangent.